All right, today we're going to simplify radical expressions. Radical expressions are just expressions that have a radical sign. Radical sign would be the square root sign. Everybody knows that as a square root. Right? This symbol right here, right, that's called the radical sign. We've talked about it when we talked about the discriminant that was under the radical sign for quadratic formula. That's the radical sign. So these are radical expressions. We have the square root of a and b. I can, at any time, break those up into the square root of a times the square root of b. The reason I can do that is because it allows me to separate things. It allows me to move things around to where I can find squares that work. Here, the square root of 4 times the square root of 9, I can multiply those, get the square root of 36. Well, do I know what square root of 36 is? Yeah, it's 6. Because now these are both squares, but later on we're gonna be doing examples where you can't. There's nothing you can do here. You can't do this or you can't do this one. But when you multiply them, then you have a square. Right? So then it allows you to work it out. So this is what we're doing. Is we're just simplifying radical expressions. So write these two examples down. Simplify square root of 80. I'm going to show you what the book shows you to do. What they do is they split up 80. They kind of factor it into prime numbers: 2 times 2 times 2 times 2 times 5. That's 2 times 2 times 2 times 2 is 5. Which then you can just break this up into this 2 squared times the square root of 2 squared times 5. What is the square root of 2 squared? 2, right? What's 2 squared? What's square root of 4? 2, right? Square root of 2 squared is 2, right? And you can't do anything to the square root of 5. So you leave it as 2 times 2 times the square root of 5, or 4 square root of 5. Okay? That's what we'll leave it as, 4 square root of 5. Right? Now, I'm not expecting you to do this and figure out all of that, right? But you do have to do somewhat of that. Like I would figure out that 4 times 4 times 5 would give you 80. Well, what's the square root of 4? 2. What's the square root of 4? 2. You don't have to find 2 square root of 2. This isn't that important when you work with numbers. Now, when you work with with variables, you kind of want to do it this way, but the more examples we'll do, the more it makes sense. Square root of 54. What could I break 54 into? 6 and 9, right? So it's the square root of 6 times the square root of 9. What's the square root of 9? Right? So your answer is 3 square root of 6. Here it'll say multiply the square roots, so I multiply these, right? Or really what I'm looking for is I'm looking for things that I can use. Can I, and I use this, I talked about a minute ago. Are any of these squares, is 2 and 14, are those squares? No, so there's nothing I can do to this one and nothing I can do to this one, right? But when I multiply these, right, I can change them into certain things, right? Which I'll show you doing it this way so it'll make a little bit more sense. Square root of 2 times, is there anything I can break up 14 into? 7 and 2. So I'm going to break that into square root of 2 times the square root of 7. Which I have the square root of 2 times the square root of 2, which is the same thing as the square root of 2 squared times the square root of 7, which was the square root of 2 squared. 2. So your answer would be 2 square root of 7. Now that's a little bit more writing than I would do or what I expect. What I would do is I would just change this into the square root of 4 times the square root of 7. Because 2 times 14 is 28, and 4 times 7 is 28. Here, square root of 5 times square root of 10. What would be a square that I could make out of 5 and 10? Is 5 a square? Is 10 a square? But can I break 10 up into anything? Okay, I could break that into 2 and 5, right? Well, is there a square anywhere of those three numbers? 5, 2, and 2? Or 5, 2, and 5? Could I make a square of any of those two numbers? 5 and 5, right? So I could do the square root of 25 and the square root of 2. Isn't that the same thing as the square root of 50? Which is the same thing this is. What's the square root of 25? So your answer would be 5 square root of 2. Alright, so it gives it asks us to simplify this as square root of 90 x cubed y to the fourth z to the fifth. Now we're going to write this the long way first, right, just so you get an idea of what's going on. 90, what could I break 90 into?
9 and 10.
Okay, I would go 9 and 10. 9 is a square. Now, I'm going to break, and we're just doing this to show you, x to the third into x squared and x. And I'm going to show you why here in a second. Y to the fourth, I'm going to do y squared and y squared. And z to the fifth, I'm going to break into z to the z squared, and z. And I'm going to show you why here in a second. All right, what is the square root of 9?
3.
Okay, is there anything I can do with 10? What about x squared? What's the square root of x squared? X. Can I do square root of x? No. You leave it. What about y squared? What can I break it into? Y. What about y squared?
1.
Y. What about z squared?
Z.
What about z squared?
Z.
Can I do anything to z? No. If it's not raised to a power, I can't do anything to it. So here's what I have left. 3 x y squared z squared, and on the inside of the radical sign I have 10 x and z, and there's my answer. So square root of 32 r squared k to the fourth t to the fifth. Alright, so I go through and I figure out what could I break up all this into. Alright, what could I break 32 into? Okay. 8 and 4, I would do 16 and 2. Okay, because 8's not a square. 4 is, but 8's not a square. But 16 is a square. Right, and that's going to give me more to work with. And I'm going to leave r squared, k to the fourth, and t to the fifth. I'm going to leave those alone. Right? Just so we don't have to write those out. You can if you want, but right, what's the square root of 16?
4.
4. 2 I can't do anything to. But think about r squared. What is the square root of r squared? R. K to the fourth. K squared. Because if you remember, right, on the problem before, we split this into k squared and k squared. We got k here and k here, which when we multiply those, we add the exponents, so we got k squared. About t to the fifth. Oh, well, it wouldn't be cubed. What you have to do is you have to think, what could I break t to the fifth into that would have a, just really when you're looking for variables with exponents, all you're looking for is an even number. So I'm going to break it into t to the fourth and t. What would t to the fourth give you? T squared, and t I'd leave alone. Right? So on the outside I have 4r k squared, t squared, and on the inside I have 2t. Right, and there's my answer. Now I will point something out to you guys. It's not something I expect you to do, but I'm pointing out so you won't get confused. On your book, if you were to look at this answer, like if this was one of the homework problems and you were looking up in the back of the book, you're going to see this. Okay? 2 lines around R. Do we know what 2 big lines around a number or a variable mean? Absolute value. Why? Can you figure out why they'd want to put absolute value around R? Right. The reason they do that is because it needs to be a positive number. Okay? It can't be negative because then it wouldn't work on the inside here. Okay? You can't, because see, we have square root of t, right? Could you have a negative number inside there? No, you can't have that. So the reason they put lines around R, okay, is they're wanting you to know that r is a positive number. No matter what r is, r needs to be positive, okay? Because it became out here, okay? Is there any way, like if r squared come out to be a negative number up here?
It shouldn't.
Absolutely not. It can't, right? Right? Because the square root is always a positive number. So, like, you can't get a negative times a, because if you, this would have to be a positive, because this can't, if this was negative and you times that by a positive, it wouldn't work, right? It wouldn't fit under here. So you know it needs to be a positive number all the way across. I don't expect you to put absolute value symbols around like a variable that's just by itself, or a variable that's raised to an odd number power, but just know that's what the book's going to write. Here, 56, x, y to the 10, z to the 5th. So I'm going to think, what can I break 56 into? Any ideas?
8 and 7.
You could do 8 and 7, but 8's not a square.
6
Okay.
and 9. No, 9.
Any ideas? Right. The only one that really works would be 4 and 14, which is just like 8 and 7, except the 2 is on the 7 side, right? One of the 2's. And then x, y10, x, z. I'm going to write it as z to the 4th and z. Okay. What's square root of 4? Okay, so that one breaks down. Can I do anything to square root of 14? No. Can I do anything to square root of x? Square root of y to the 10. Think about it. Right? With variables, it's a little different. Right? Y to the 10, I could go y squared times y squared times y squared times y squared times y squared, right? Each one of these is going to give you what? Y. So what would y square root of y10 give you? Y to the 5th. Okay? That's why it's a little different. You think, well, how can I get an odd exponent? Well, when you're working with variables, it works out that way. Z to the 4th, what would I get? Z squared. Right? Can I do anything as z?
No.
No. So on the inside, I have 14 x z. Right? Now, again, I'm just going to point out what the book's going to do, just so it doesn't confuse you. It put absolute value, it put absolute value symbols around something on the outside. Can anyone guess what it would be? Y to the 5th. They did that right there, because it needs to work out to be a positive number. Right? If it worked out to be a negative number, it wouldn't work with what we did in here. So the only way for this to be a true statement is as long as y to the 5th comes out positive. So to guarantee it, you put around the absolute value symbols. But again, not necessary. All right, write this. So here, it wants you to simplify. Well, when you have a fraction like this, we want to rationalize the denominator, because you can't have a fraction with a radical sign on the bottom. Right? Because what happens when you do this, you get square root of 35 over the square root of 15. However, you're not allowed to have a square root on the bottom sign. You're not allowed to have a radical sign. So what we need to do is rationalize it and see if we can get rid of that radical sign. Is there anything I can take out of 35 and 15?
5.
Okay, I could take out 5. So I could reduce it to the square root of 7 over the square root of 3, because I took 5 out of both of those. Now, to rationalize this, if it's just like this, where it has like square root of 3 on bottom, what I do is I take the top number and the bottom, I times the bottom number with the same thing by putting on top, and I put it on bottom. I multiply both sides by the square root of 3. And what that does is it gives you square root of 21 on top, but on bottom it gives you 3. Because what's the square root of 3 times the square root of 3? Square root of 9. Which, what is the square root of 9? 3. Up here you had square root of 21. So when you time something by itself, right, you make a square, which gets rid of the radical sign. So that's what you do, is you just you times it by the exact same thing. In most cases, not in all, but in most. All right, write this down. So here they've got square root of 6y or square root of 612. Is there anything I can take out? All right. So it leaves you with square root of y over the square root of 2. Right? How do I get rid of the square root of 2 on bottom? I take the square root of 2 times the top and bottom. So on top, I have square root of 2y. On bottom, the square root of 2 times square root of 2 gives me square root of 4. So I can't do anything square root of 2y, but the square root of 4 I can reduce to 2, or I can simplify it to 2. So there's my answer. 3 over 5 plus the square root of 2. Now this is a little different. Okay, this is a binomial, okay, with a radical sign. And they're what we call conjugate. So what we do is we times by what's called the conjugate. To get rid of 5 plus the square root of 2, we times by its conjugate, which is 5 minus the square root of 2. Which what we do the one side, we have to do the other. So we have to multiply both the top and bottom by 5 minus square root of 2.
I'm so confused. How do you do that?
This is just what you do. Okay. What's the only difference between this and this? This is plus, this is minus. So this is minus, this is plus. I'm just timesing it by the opposite of it, which is called the conjugate. Right? So nothing I can do to the top other than just multiply that out as 3 times 5 minus square root of 2. But on bottom, right, it gives me 5 squared minus the square root of 2 squared. Right? And the reason I know that is because these are opposite. Right? And we've done problems like this where we've multiplied the opposites. Right? Remember a squared minus b squared? Right? How did we get that? We took a plus b times a minus b. Right? Remember that? Okay? So that's just what we're doing, but in opposite order. Okay? So instead of factoring it this way, I'm multiplying these to get this. So 5 times 5 gives me 5 squared. Square root of 2 times negative square root of 2 gives me this. Which what's 5 squared? 25. Minus, and what's 2 squared? What's the square root of 2 squared? Okay, it's just 2. Alright? Which on top, okay, we just simplify it out. We take 3 times 5 and get 15. We take 3 times square root of 2 and get 3 square root of 2. We simplify the bottom. So my answer is 15 minus 3 square root of 2 over 23. And that's my answer. Alright, so since we have a radical sign bottom, we have to get rid of it. We have to rationalize it. Right? And to do that, we're going to use the conjugate. So I'm going to times this whole thing by 3 plus the square root of 7. Because that's the conjugate of 3 minus the square root of 7. All I'm doing is I'm changing the sign. Okay? So now I just multiply those out. So I take 7 times 3 plus the square root of 7. And on bottom, I do the first thing squared minus the second thing squared. And I can write it like this. You don't have to, but I'm just doing it so you understand what I'm doing. So distribute 7 out. So you get 21 minus 7 square root of 7 over, what is 3 squared? 9 minus, what is the square root of 7 squared? 7. Okay. So 21 minus 7, square root of 7 over 2. There's your answer. Here's your homework assignment.